The next thing we're going to do is we're going to clip our rasters, and we're going to use our graphic area of interest to clip our raster data files. We will be presented with the option to place our raster files into a geodatabase at a spatial projection if desired during the clipping process. Sometimes you may need to reproject the data. You don't necessarily have to clip it, like it may already be clipped down to the size that you need it to, and you only have to reproject. And if that's the case, then I want to show you the tool to just do a reproject. That way you don't have to go through the whole process of data extraction. You can simply go to the Data Management Tools in the ARC toolbox, Projections and Transformations, and then remember there's two types of data. There's feature and there's rasters. So for reprojecting rasters, we would just expand this raster tool and then use this project raster tool here. So I just double clicked on it to open the tool just so we could take a look at what our options are here. So you would put your input raster in here, and then your output raster, you'd specify where you want that to go, and then you specify the new coordinate system for it. And we're not going to do it that way because we actually need to clip and reproject, so we would only use this tool if we only need to reproject and not clip. So I want to make sure that I have my graphic area of interest selected, and I do because I can see my handles. So I'm going to right click on this RL_2010 nape.sid. I'm going to go to Data, and I'm going to select Export Data. And then we should have this window that opens. So we see here in the extent, we have selected graphics clipping, we have that dotted in. And if this is grayed out to you, this is because you don't have your graphic area of interest selected. Remember, to select it, you need the Select Element tool activated to select things in the data view. Over here where it says Spatial Reference, well, we don't want to use the raster dataset, the original spatial reference, because that is set to NAD 1983 UTM Zone 14N. So this is actually in meters and we want it to be in feet. So we're going to use the data frames, which is going to change it to NAD 1983 State Plane, Kansas North, FIPS 1501 feet. And we can see here in the cell size that it's automatically being converted. So we can see our cell size is now 3.2808, so it was 1 meter by 1 meter. And then the location, we need to specify the location where we want this to go. Well, I happen to know that I don't need to do anything more with this raster, so I can go ahead and just put it directly into my geodatabase. In fact, that's what I'm going to do. So I'm going to click on this folder button, and I'm going to navigate to where my geodatabase is located. And I'm just going to select it because it's just asking me to select a workspace. So I just have this workspace selected and click Add. And then down here where it says name, we need to specify a name. And this is actually quite long, so we need it to be 8 characters. So we're going to call this Marlet Park Aerial. Maybe we put a 2 on the end. Kind of 9 characters long. It's a little bit long, so maybe I'll just hack off the IAL on the end here. So I'm calling this MP Aerial 2, or maybe I'll just call it Aerial 1. And I'll just add an A to the end to indicate that this is Marlet Park Aerial adjacent land uses. And everything else looks the way that it should, so I'm going to go ahead and click Save. See down here that it's processing. It's asked me, do I want to add the exported data to the map as a layer? I'm going to click yes, so it should appear over here in my data frame. And I'm going to turn off the bigger one, so now we only have the smaller one. So what we've done thus far is we have clipped our aerial, and we have clipped it. The reason why we are clipping our aerial is because we need to clip it down to a manageable size to avoid huge unnecessary use of processing power. So I'm going to do the same thing with my surface data, except I'm not going to put my surface data into a geodatabase just yet because I have more work to do with it. I'm going to right click on this and go to data just as before and choose export data. I notice that it says selected graphics clipping is selected. I want it to match my data frame spatial projection, and this time I don't want it to go into the geodatabase. I'm going to save this into my rasters directory. I'm going to create a folder in here called DEM. Remember, it creates a bunch of companion files and we don't want to be confused, so we're just going to contain them in this DEM directory. I'm just going to select DEM as my workspace and then click add. And then I'm going to give it a name. I'm going to change the format to a grid. So I'm going to give it a name. I'm going to call it MP LDR 2 meters to indicate that this is 2 meters. And then I'm going to go ahead and click save. And we notice that it's already being converted, so we know that our cell size is 2 meters by 2 meters because it's the 3.2808399 multiplied times 2. I'm going to go ahead and click save. I'm going to click yes to this window, turn off the bigger one so that we see our smaller one. So I'm going to go ahead and do this for all my rasters to minimize unnecessary processing power. So I'm going to go ahead and do this for all of my rasters to avoid huge unnecessary use of processing power. Data files that I need to do more with, I'm not going to put into the geodatabase yet, but raster files that I know I don't need to do any more with, I'm going to save into the geodatabase.